Today we're going to continue looking at methods to display numerical data, and the method we're going to look at is stem and leaf plots. We're also going to use our CAS to do some of the legwork for us, and we're going to also use the CAS to generate some histograms. So exciting lesson. All right, what is it? It's generally, a stem and leaf plot is generally ordered. Okay, that is, the data is ordered smallest to largest, and it's a good way to display numerical data. This is just a kind of a ballpark figure, but maybe 30 pieces of data would be appropriate. 10 is fine, 5 is just a little bit too few data points. Once it starts getting too big, say 50, 60, the stem and leaf plot starts to get too big and too cumbersome, and we generally go to another method to display the data then. Okay, the best way to explain what a stem and leaf plot is to actually start one up. So what we've got here is 20 people were surveyed to find out how many times they use the internet in a week. This person here obviously used it 21 times, 19 times, then another person's 5 times, 10 times, etc. Okay, so what we usually do is draw like 2 lines like that, and that's going to form our stem. Okay, and this part here is our leaf. Okay. All right, so what I want you to do is just pause the video now and type in the data. I've done it already. All right, so now you should have the data in, and what I want you to do is make sure anytime you check the data or you type in data, you check whether you've input it correctly. Now you can't do that for sure, but a good way to do it is to say 20 people is in the question, and this 20 lines up with the last data point you've typed in. So it probably went in correctly. All right, now what we're going to do is edit and sort in ascending order. Now remember, what it does is it says, how many lists have you got me to sort? And the answer is 1 list at this stage. And it says, what did you call the list? Well, I recommend not changing or ever changing the names and just use the default. So it's in list 1. So notice here that we've got list 1. I would never rename these columns. Okay, that's my personal opinion. All right. Now what we're going to do is form or get an idea of what our leaves are going to be. So we note here that we've got 40 is our highest value and 2 is our lowest value. Now a leaf is only ever going to be single digits. So our stem goes here and our leaf goes here, and our leaf has to be single digits. Okay, so what we're going to do is my first stem I'm going to put in is a 0. Then what I do is I add the leaf to that, which is 2. All right, and then 5. Now, if I was processing this stem and leaf plot to make the numbers, what I do is I grab the stem, write that down, and then grab the single digit, which is 2, and that would be the number 2. Then I'd grab this, so that would be the first number. Then I would grab the leaf again, or the stem rather, and then I'd grab the second leaf, which is 5, and that would recreate the second number, which is 5. Okay, so what we're doing is basically processing this and in a way kind of making a histogram, except the column or the bar that we're using is in fact made up by numbers rather than like a box or a rectangle or whatever. All right, so let's keep adding to it. So our next stem is going to be 1 followed by a 0, because that would, when connected, make the number 10. Then we've got 11, then we've got 13. Now note here that what I'm going to do is make sure my numbers roughly line up. Like, you don't have to measure it up or draw lines or anything like that, but make sure like you got 1 element and 1 element, or 1 data point, 1 data point, 1 data point, 1 data point. So they should go roughly underneath each other. So then we got 4, then we got 5, 6, 8, 9. Okay, so they're all the ones in that. Now we don't need to put commas in there because it's always implied that to make or remake the data point, what you do is you grab the stem and the single digit and stick them together. That's always the way we do it. All right, our next stem is 2. So again, I'm just looking at the numbers off the calculator here, and we've got 1, we've got 4, we've got 5, we've got 8, and we've got 9. Now to 3, we've got 1, 1, 2. Then we've got 3, and then we've got 4, and we've got 0. All right, so here's our finalized stem and leaf plot. And what we can quickly see from the display is that the most common group of internet, or number of times the internet was used, was between 10 and 20 times, okay? And we can quickly see that, like that's the biggest bar there, okay? So a couple of things that we need to do. We need to write a key, okay? And this explains what each of these things represent. So you can choose any way to form the key. So I can sort of choose 1, 0 is 10 uses of the internet in a week. All right, so that key is crucial to explain how to use the chart. Like when I stick them together, what does the result mean? Okay. Now, the other thing we'll do is make sure that we give our chart a heading. So, number of times internet is used per week. All right, so there's our first stem and leaf plot. So here is again in the notes what I've just explained, which like between you and me, if you asked me to create a stem and leaf plot and left the data like that, it would be a nightmare, because what I've got to do is fish through and find the smallest value and then the next smallest value. And invariably, girls, what I end up doing is missing one. And that spoils everything. I have to get like the liquid paper tape out or the rubber out and remove everything. But once it's ordered smallest to largest on the calculator, it's really easy to process it. Okay, so what we can do also is do these back-to-back stem and leaf plots, okay? That's a great way to compare data. So what we've got here is a back-to-back stem and leaf plot, and it represents pulse rates before and after gentle exercise. So this side here represents after, this side here represents before. And what we can actually quickly see is after some gentle exercise, the pulse rates that were measured seem to be higher than before, which seems to make sense because I mean, like I'm no expert on like the physiology aspect of it, but when you work or ask more of your body, the heart pumps faster to circulate the blood, yeah, so that's what I'm expecting to happen. Okay, so here before gentle exercise we had these heart rates here, and after it seems to be much higher. Now we certainly need a key. All right, so here's our key on this side. So we're going to say 86 is 86 BPM. All right, so that's the key for this side. Now this side is going to need a different key. Okay, now why? 86. So we're doing this one here is 68 BPM. Right, and so what that represents there is that number there, 68 beats per minute. Now, if you look at it, it looks like it's 86. But actually remember, to reconstruct a number, what you do is you take the stem and you add the leaf to it. So that's 68 there. This one here represented 86 because we took the stem and we added the leaf to it. Okay, so note the difference on this left-hand side. So don't forget those keys, girls. They're very important because they explain to people how to use your display. All right, there's some other conventions. So sometimes, girls, what we have is a situation where, like this data here, we've got data that falls between 52 and 77, and that's a fairly narrow range of data points. So life expectancy. So what we do, this is called splitting the stem. Okay, so what it does is it kind of spreads the data out a little bit more and gives us a better idea of how the groups might be formed. So what happens here, there's supposed to be an asterisk here and an asterisk here and an asterisk here. And what happens is we split the fives into two separate categories, I suppose a bit like rounding numbers. This category of fives represents 0, 1, 2, 3, and I forgot 3, and 4. I.e. 5 digits. So if a number ends with any of these 5 digits, it gets slotted into this part here. if a number ends in the digit 5, 6, 7, 8, or 9, any of those 5 digits, means it goes into this part here. So it's called splitting the stem, and it involves, dividing it into 2 parts. And what it does is it gives us a really good or a better impression of how the data came out. And what we can clearly see here is that the life expectancy, or the most common life expectancy, was between 70 and 74 years. That would be much better than saying, if we didn't split it, saying between 70 and what would be 79 if we didn't split this stem into 2 parts. Okay, so all it does is allow us to do that. Now, I usually consider splitting the stem if I've only got, say, between 3 or 4 kind of value points. So if we look up at this one here, no way would I consider splitting the stem there. There's no need. This one here, we've got 1, 2, 3, 4, 5. That's probably the limit to do single stem. If it was one less than that, I would actually split that stem to get like a better idea of those heart rates. So there's no hard and fast rules with stats, and that's what some people don't like about this topic. No one actually wrote the book that said when the number of groups is equal to 3, you must split the stem. It's only just like an idea, okay? All right. We can also represent decimals quite easily. So note that this is 12.3, 12.5, and 13.0. In a stem and leaf plot, we would write 12 as the stem, 3 as the leaf, 13 as the stem, 0 as the leaf. How do I know that it's a decimal? Well, you've got to put a key, all right? Without that key, I wouldn't know what these things represent, and I'd just reconstruct the number as 123, 125, and 130. But with the key that explains how to use it, I can know, so that's like a decimal point in there, okay? So same over here, what we've got, we can put 1.23, 1.25, we can easily put that into a stem and leaf plot. Like I've got 1.2 with 3, so I write the stem down and I put the leaf on there, 1.23. And again, very important to specify units or context in your key to explain exactly what it represents. All right, so the final thing I'm going to do is show you how to construct the histogram on your calculators. So what I want you to do is pause the video now and type that data in, and I'm going to do the same thing, okay? Now note that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 data points. Okay, so again, it's crucial that you check for errors. Like, so I've got 21. So that means I've probably entered the data correctly. I'm not 100% sure, but at least I've got like one way that I can check that I've got at least all of the data points. Okay. All right, so here is the basic process. So what we're going to do is type the data in, okay? Then what we're going to do is go to this option here called Set Graph, okay? Now, what we can actually do is have 9 different types of stat graphs, but we only want one at this stage, which is a histogram. So what we do is we check or make sure that stat graph 1 is checked, and it should be by default, and we go to the settings. All right, we've got all sorts of different graphs that we can draw. So it's just like if I drop that list down, these are all the different types that I can draw. So a lot of these you'll go on to use, or some of them you'll go on to use in general mathematics, further mathematics. Now, what we're going to draw today is a histogram. All right, so the histogram then basically says, once I select it, it goes, hey, where are your values? Where did you store those values? And what we did was we popped it into list 1 by default. Now, if you put it into list 2, you just need to make sure that you change or drop that and get it to point to the correct list. Now, FREC means frequency, and if your data is in a frequency table, you can explain where you put the frequencies, i.e. I put the frequencies of those data points into list 2, list 3, etc., etc. If you haven't got it in a frequency table, which generally speaking you won't, you leave that as the default option, which is 1, which is the calculator's way of knowing that it's not in a frequency table. All right, so once you've done that, this is setting the properties so that when I graph it, it's going to look for these kind of properties. So you just hit set. Right, now what a lot of students do in exams and things like that is they go, I've set the graph properties and it's not graphing it for me. You've got to hit the graph button. Okay, so now you've set the properties. Now when you hit graph, it goes and looks for the properties. Now that's the graph button right there. So you hit that. All right, now what it does is it's going to ask you a couple of questions because it's still not sure how you want to do this. So it goes to you, all right, where do you want to start this histogram? Like how low do you want to start it at? Okay, usually the question will give you an idea of the start value. So this one says here, can you please start it at 0? All right, so that's the start value. So it basically starts grouping the values from 0. Now this step value says what interval do I want to use or how big do I want the groups to be? So that's how fast it steps up. So this one suggests that we use a step up value of 3. So we're going to increase by 3 each time or group them into 3s. So we hit OK now, and there's our histogram. All right. So we can process the histogram quite easily. So what we're going to do is go analysis and trace. All right. Now what we do is we hit these arrow buttons here to navigate. See that like thing there is the target, right? And that says basically this group here has 0 items. It's got a frequency of 0. Right, when I hit right, it's going to say that the group starting at 3 has 0 items in it. The group starting at 6 has 0 items. Pretty unexciting at this point. The group starting at 9 has 2 items in it. The group starting at 12 has 0 items in it. The group starting at 15 has 2 items in it, etc., etc. So I can actually go through and process my histogram then. Now, just say you do that and you're like, I'm not really happy with that and I want to change it. Feel free to exit out of that. So see how these blue lines are around this window? That means that that window is selected. You can get rid of that window by hitting the X. All right. Now what you can do is graph it again and it will ask you the question again. Now what the calc does is try to predict the interval by going to the lowest value and giving you a rough step value that might produce a decent sized column. Usually it's wrong. Okay, so again, what we're going to do is go to 0 as the start value, and I'm going to step it up to 10, up to not including 10. All right, so there's our new one there, and we can again go to analysis trace, and that might be the one that you get. And so a question might say something like, ensuring that you have only a maximum of 5 groups, draw a histogram for the following. Now you could play with this data for a while and do it, but you can get the calculator to draw it up fairly quickly for you. Okay, so that's how I draw a histogram on the calculator. All right, so your set work then will be to finish off worksheet 2. I think question 6 onwards now are good to go, and then jump over to worksheet 3 on stem and leaf plots.